This is my reassessment for Standard 2. A tennis ball has a mass of 0.057 kilograms. A professional tennis player hits the ball hard enough to give it a speed of 52 meters per second. The ball moves towards the left, hits a wall, and bounces straight back to the right with almost the same speed. As indicated in the diagram below, high-speed photography shows that the ball is crushed about a distance of 2.7 centimeters at the instant when the speed is momentarily zero before rebounding. Okay. So first of all, we want the average speed of the ball during the period from the first contact with the wall to the moment the ball's speed is momentarily zero. So, can you see this? We have to use V average, or the average velocity, which equals velocity 1 plus velocity 2 divided by 2. So the average velocity is 52 meters per second. And we find that up here where it says the speed, and we divide that by 2, and we get, the first one is 52 meters per second, and then the second one is 0 because it hits the wall, so the velocity is 0. And we divide that by 2, and we get 26 meters per second. Okay. Now, under the second part, asks us how much time elapses between first contact with the wall and coming to a stop. So we have to use right here the average velocity of x, as you can see. Okay, so the average velocity of x is 26 meters per second, and the change in x is 2.7 centimeters or 0.027 meters. The change in t equals, when we solve for the change in t, it equals the change in x over the average velocity, which will equal 0.027 meters divided by 26 meters per second. And that will equal 0.00104 seconds. Now the problem asks us, what is the magnitude of the average force exerted by the wall on the ball during contact? So, for that one we have to use the average force. And that'll be change in the momentum over change in time. Change in momentum is mass times the velocity 2 plus mass 1 times velocity 1 divided by change in time. So change in momentum will equal 0.057 kilograms times 52 meters per second. And we only use the first one because the velocity 1 was 0 when it hit the wall. So we just use this one, the velocity 2. And we divide it by 0.00104 seconds, and we will get 2,850 newtons. And now it asks us, in contrast, what is the magnitude of the gravitational force to the earth on the ball? So there we have to use the equation mass times the gravitational force. Yeah. And that'll equal 0.057 kilograms times 9.8 newtons per kilogram. And when you multiply that together, it'll equal 0.5586 newtons. And that is my reassessment for Chapter 2.